Go ahead and fill in your geology notes as I fill in the blanks here. So we have Alfred Wegener. About 100 years ago, he proposed continental drift, and he said that at one time the continents had been joined. And so the second one here, when, if you look down here, says that the continents are in constant motion. They move at a rate of centimeters, so I'm going to put cm per year, and that there used to be a supercontinent. Now this is a review from biology. You probably learned that the supercontinent was called Pangaea before. And so this picture here shows the supercontinent where all of the land masses were combined. And so what continental drift is up here now. So we have the different layers of the earth. At the very top we have the crust where we are. It's a very thin layer. And in the middle we have the core. But the crust is, well, the more official name is the lithosphere. And it has the crust and the upper mantle. And then we have the crust that's broken up into many different plates. You can pause the video as you need to. Down here is a picture of the globe with the different plates. We are at this place right here. I'm kind of drawing a yellow dot. So in Santa Clarita, we are on the Pacific plate. And then once you get about to Palmdale, which is about 20 miles east of us, you are on the North American plate. And so the lithosphere is broken up into 8 major plates and many more minor plates. We are on the Pacific plate, which is one of the major plates. So why do these plates move? They move because of something called convection. So under the Earth's surface, we have hot lava here. Okay, and underneath the crust, it's called magma. And so hotter magma rises and cooler magma falls. And then hotter rises and cooler falls. And it does them in this circular shapes. So hot material rises and cool material sinks. Now it's all magma, so it's all hot. So we can't say it's cool magma. It's cooler magma. It's not cool by any means. It's magma. It's lava underground. And so these are the things that move the plates. So the plates, the crust is above this, and so this crust is going to move this way, and this crust is going to move this way, pulled by this lava underground, this magma underground that's moving in these circles. And the circles are called convection currents or convection cells. They're synonyms. Okay, so at these different plate boundaries, we have 3 different processes going on. So you can see all of these lines here are the plate boundaries. Some of the plates are sliding past each other, some are going apart, some are coming together. So let's take a look at these. So the first type of plate boundary is coming together, and this is called a convergent plate boundary. And so again, we can write convergent. And the plates are moving toward each other. So plates, when they're doing this, one of three things happens. Plates can push up to form mountains. Or one can slip beneath the other in something called a subduction zone. And we're going to sketch this out together. The next one is called divergent, so it's moving apart. And under all of these plates is magma. So we have hot magma under all of these plates. These ones, it's under here. It doesn't come into play with transform plate boundaries. Okay, so when these plates are moving apart, well, this is usually in the ocean. So we have this underwater, and I'm going to go ahead and draw a fish to show you it's underwater. Most of this process happens in the ocean. There's a famous one called the Mid-Atlantic Ridge where this is occurring. And so what happens is lava seeps up, and it's going to hit the cold ocean water, and then it's going to solidify. And so you have these underwater mountains here, and the mountains get kind of pulled along with the crust. And so new mountains form with more lava, but then they kind of get pulled to the side as the crust keeps getting pulled. The only place you can see this on land is in Iceland. The Mid-Atlantic Ridge on land, sorry. You can see divergent plates on land also in Africa, the African Rift Valley. So they're moving away from each other, and new crust is formed when magma rises to the surface between the plates. The next one is transform plate boundary. This is the type we have. And this is where the plates slide past each other. And it doesn't do it all the time because friction causes them to stick. And then when the pressure builds, it releases all at once. And the plates move quite a lot at one time because the pressure builds and it forms earthquakes. So now you're going to go to the back of your paper or a blank sheet of paper, and you're going to title it. Oh, I forgot to write a title, so let me go ahead and add that now. Types of convergent plate boundaries. So we have three different types of convergent plate boundaries. The first type of convergent plate boundary, and so these are ones coming together, is when you have two continental crusts coming together. So we have two different types of crust. We have oceanic crust and continental crust. And continental crust is made out of granite. So you have two granite crusts with the same density, and so they're coming together, they're butting up against each other, and they're hitting each other, but because they're the same density, they're going to push each other up. And they're going to form mountain ranges. And the most famous example of this is the Himalayas in northern India, where Mount Everest is, the tallest peak in the world, is going to be here in this process. So Mount Everest is continuing to grow taller because the plates keep pushing and making it grow. The second type of convergent plate boundary is when we have oceanic crust and oceanic crust. So oceanic crust is made out of basalt, and continental crust, like we learned, is made out of granite. And basalt is more dense than granite, so it's going to subduct below the other. So we have here called subduction. Now this is mostly happening under the water, so I'm going to draw my ocean here. I'm going to make it hit the land, and I'm going to draw a fish to show you that's underwater. And down here is our magma. All right, so basalt, because it's more dense, will slide below, but what happens is that the friction, it gets caught, so the plate kind of gets caught and bent down a little bit, and it creates these fissures and cracks. And then magma seeps up through these cracks and comes out of the ground. When it does that, it's going to hit the cooler air and it's going to solidify into rock and create igneous rock. And then more is going to come out and it's going to turn into igneous rock. And over time, we're going to build this mass of land, which we call a volcano. And a lot of volcanoes are still growing to this day. The most famous examples of this are on the coasts of Oregon and Washington. And so there's a line of volcanoes, which we call the Cascade mountain range, that are all volcanoes. And one erupted in the 1980s. They had a big eruption, and it even erupted like 10 years ago, Mount St. Helens. The others are considered dormant, not extinct anymore. We used to think that volcanoes went extinct, but they don't. They just sleep for a little while, they go dormant, and then they can become active again. So there's a whole line of these volcanoes along the coast because the plate boundary goes for several hundred miles, and so it creates this type of thing all along that coast. We don't have this situation off of our coast in California, so we don't have the volcanoes down here. We also don't have a huge tsunami risk because here's what happens. So over here, the plate gets bent, and then eventually it snaps back. And when it does this, all this water is displaced. And it creates this huge amounts of energy, and so the energy goes in the form of waves and creates a tsunami on shore. And so Oregon and Washington have a big tsunami risk off of their shores because they have this subduction zone right off of their coast.